So my name is Sam Hawke, and this is my term project for 15112. It's called MatrX Cartesia. I made a mathematical software that can do matrices computations and graphing and a little bit of statistics. So let's take a look. So for matrices, these are the different options. One particularly useful one is solving linear systems of equations. So if you have n equations and n unknowns, you can go back and forth and pick entries for your matrix. And it works for any arbitrary numbers that you pick. So say these are your numbers, and you can use the arrow keys to move around. And so, yeah, these would be like the coefficients to your equations. And then over here, this is your target vector. This would be like what you're trying to get those equations to equal. So you typed in all the numbers, and you can use C to compute, and that's your answer. So that's a very useful thing. Under matrices, we can also compute the determinant of a matrix. So if we have, say, a 4x4 matrix, and you wouldn't want to do this computation by hand because it's a lot of computation to do. And in fact, here the algorithm uses recursion, so that's pretty cool. Again, you can put in like even very large numbers or large negative numbers. And yeah. So this is pretty cool. And then you hit C again to compute, and that gives you the determinant that you really wouldn't want to have to compute. So yeah, and then one last thing I want to show you in matrices is the LU decomposition. So because we have a Gaussian elimination function, this one was very easy to write. So you can type in a matrix, and then you type in entries for that matrix. And this LU factorization, basically what it does is it rewrites your matrix as a product of two simpler matrices. And I find that that's generally a big theme in math, that you want to take more complicated looking things and make them as simple as they can possibly be. So yeah, you'll take this, and then again, if you hit C, it'll factor this matrix into L, which is a lower triangular matrix with zeros above the diagonal, and U, which is an upper triangular matrix with zeros below the diagonal. So yeah, those are just some of the matrices things that you can do. There's also data and statistics. So here you have one variable stats options and two variable stats. So under one variable stats, you have your one variable data, and you just type it in. You can pick whatever you want. So say this is your one variable data. Again, you hit C to compute, and it'll draw your box plot and give you all your one variable data, in addition to sorting your list. So yeah, that's pretty cool too. That's nice for organizing data. And under two variable statistics, it does something similar, but you have to type in bivariate data. So again, it can be arbitrary entries. And let's say these are your data. I want to show off nice data here. So this would be your scatter plot. And if you hit C, then we'll compute your regression line and draw it. So there we go. That's your two variable data on your X and Y axes. And here we drew the regression line and computed the coefficients and the correlation coefficient here. So those are some of the statistics options, and then here's the real cool part. In graphing, you can graph real functions, and then you can visualize linear maps in the xy plane. So for the graphing real functions option, you can graph up to 3 functions, and you have to type it in valid Python code. But here, if you have like f of x equals x, or g of x equals, let's say, 1 minus x squared, or let's say h of x equals x double divide 2, so that'd be like a step function, and you hit enter, and then we have a graph of all 3 functions visualizing it. So yeah, this is an option, and you'll notice that we also have a step and a max. So if you use the right arrow, you can come over here to this box and scale it to however you want it to be. So say we want the x step and y step to be greater, and we want to zoom out basically. So there we go. Just like a graphing calculator, you can zoom out. And you can adjust these to be whatever you want them to be. So yeah, and then click to return home. And now we can visualize linear maps in the xy plane. And so that involves typing in a matrix here and visualizing the linear transformation that occurs. So since this is a linear transformation, because we're multiplying by a matrix map, that means that what we're going to visualize here is either a reflection or a rotation or stretching or shrinking the vectors. So if these are standard vectors, we can also think of this as a change of basis. So let's type in a matrix here. And if we hit enter, then it's going to animate from its beginning to its final positions. We can try again with a different matrix. If we just try like twice the identity matrix, everything's just going to zoom in too. So that's exactly what happens. And one interesting thing is, if you actually apply these linear transformations more than once, you can think about it as applying the function more than once. So that'd just be like multiplying by this matrix squared, and it actually works. If you just hit enter one more time, here we have an iteration of this function twice. So yeah, that's my term project for 112. Thanks for watching. Oh, here's the credits screen.